Alright guys, first thing we're going to look at is polygons, and so to start off with, we better know what a polygon is. So here's what it is. It's a closed two-dimensional figure. Now the closed part of that means that it's not going to have any gaps in it. It's going to connect all the way around. Two-dimensional means it's flat. We're not talking about something in real space. Something that you could draw on a piece of paper is what we're looking at. So I'm going to put two figures up here. This is a polygon. It's closed. There are no gaps in it, and it's two-dimensional. There's not any three-dimensionality to this. This is not a polygon. The reason being it is not closed. There's an opening left in this. So this one is not a polygon. This one is a polygon. Next thing we're going to look at is how to name these things. That is, if I have a polygon in front of me, how do I know what to call it? And the answer is that we count up the number of sides. So if I look at this one, I would count the number of sides on this polygon, and that would tell me what its name is. So again, polygons are based, or polygon names, rather, are based on the number of sides. All right. Now here's the master list, and the bad news is you will have to memorize this list. I've only put the common ones on here. There are actually names for these farther than any of us want to go out. I think maybe even up to 1,000 they have names. Not even sure, because really these are the ones that get commonly used. If you need to pause this video, write those down, commit those to memory right now. I'll run through it if you're looking, or if you're trying to write this down as it plays. Three-sided figures are called triangles. Four-sided figures are quadrilaterals. These are the only two that have alternate names. Sometimes, extremely rarely, not very often at all, you'll hear a triangle called a trigon, or a quadrilateral called a tetragon. But that's pretty rare. Usually it's triangle and quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides a heptagon. 8 is an octagon. 10 is a decagon. And 12, which we include mostly for historical reasons, is called a dodecagon. Alright, now that we know how to name them, that is, if I put a figure in front of you, you can count up how many sides it has and you can tell me its name. The next thing we want to do is describe it. So these are just some adjectives that we attach to the name so that we can give further information about it. And the first one we're going to look at is equilateral. And this means just what it meant with triangles. An equilateral polygon has all sides congruent. That is, all sides are the same length. So for instance, if I said I had an equilateral pentagon, that would mean that I had a pentagon with all sides being the same length. Equiangular, just like with triangles, this means that all the angles are congruent. So if I had an equiangular, say hexagon, all the angles inside that hexagon would be equal. And then if it turns out that both are true, you're going to have what's called a regular polygon. So for instance, a regular heptagon would have 7 sides that are all congruent and 7 angles that are all congruent. So these 3 are tacked on to the name to give additional information about it. We also have 2 other labels that we can add. One is convex. This means that there are no inside angles greater than 180 degrees. That is, all the angles in the figure will point outward. And if that's not the case, we call the figure concave. That is, at least one of the angles on the inside of the figure is greater than 180 degrees and so points in. Now, odds are good that that makes no sense whatsoever without a picture, so let's look at a picture of that. So I've got these 2 polygons here. This one right here, which, let's move this up to the center some. This right here would be a convex polygon. If we look at it, all the angles, and so the angles would be there, 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 and there, all the angles point outward. That is, if I were to take the measure of these, none of these are greater than a straight line. They don't curve in. Another neat way of looking at a convex polygon is you can take a line and you can draw any line through it at any point. In fact, why don't I just? So I can draw a line through it like that, and it's only going to touch the polygon in 2 places. And it doesn't matter where I choose to do this. Any line I draw through the polygon is only going to touch it twice. If that's the case, it's a convex polygon. This one here is a concave polygon. You can see this angle right here points inward towards the center of the figure. If we were to measure it, it's greater than 180 degrees. That is the angle that is right there. So it comes all the way around there, is greater than 180 degrees. That makes this concave. Notice too, conveniently, that these are polygons that are slightly caved in. And if I try my trick over here of drawing a line through the polygon, well, some places I can draw a line through it and it will touch in just two, but there are other places where that is not the case. If I draw lines through it there and there, you can see that it touches the polygon in 4 different places, meaning that it must be a concave polygon. So a polygon is just a closed two-dimensional figure. We name it based on the number of sides, and then we can add descriptors to it. Equilateral if all the sides are equal, equiangular if all the angles are equal, regular if both of those last ones are true, convex if all the interior angles are less than 180, and concave if we have one angle greater than 180 that kind of points inward.